So in a previous lesson, we looked at how a quadratic function changes. Okay, and then we kind of looked at the quadratic function and we looked at the changes in the y value of the quadratic function. And the changes in the y value seem to follow a linear pattern. So this is something we're going to expand upon a little bit more. So when we look at functions, we often want to understand how a function changes, or the change in y. And when we look at the change in y, it tells us a little bit about the original function. So for example, when we see a linear change of y, we can see that that probably is a quadratic progression. Okay, so when we look at quadratic, this perfect squares, 1, 4, 9, 16, we can see that it's plus 3, plus 5, plus 7, etc. So that this change, this linear change, tells us that this, whatever this function is, this function happens to be a quadratic. This is a perfect square, but all quadratics have that property. And later on, we want to look at something even more important, which is called the rate of change, or the change in y, or the change in x, which is essentially slope. And when we look at the rate of change, we can find a function, some calculation that actually gives us the rate of change. And in calculus, this is given a special name. It's called the derivative. And this is very important when we get to calculus. So we're just going to investigate this a little. And if we look at the patterns of change in y in parabolas, okay, so we take a look at the change in y. So this is a y equals x squared. So negative 3 squared is 9, negative 2 squared is 4, etc. So when we look at the change in y from 9 to 4, we have a plus, looks like, sorry, it's a minus 5 change. Okay, so we end up with a minus 5 change. From 4 to 1, we have a minus 3 change. From 1 to 0, we get a minus 1 change. From 0 to 1, we get a plus 1. Okay, and again, notice that the change in y is now following a linear pattern. So negative 5, negative 3, we're going up by 2's. So the change from 1 to 4 is going to be plus 3. So we can see that this quadratic function, the perfect square function, has a linear change. Okay, same thing here. We can take a look at the change in the y values. Okay, so this is, again, we're just going in steps of 1. And this function here, negative 3x squared minus 5, calculates the y coordinates here. And we can look at the changes in y. So negative 17 to negative 8. Okay, so we'll go negative 8 minus negative 17. We get a plus 9. Okay, that's going to be a plus, from negative 17 to negative 8 is plus 9. Okay, from negative 8 to negative 5, we get plus 3. Okay, so negative 5 to negative 8, we get minus, looks like minus 3. Okay, so we go from negative 17 minus negative 8, we get a plus, sorry, that's minus 9. Okay, and then from negative 17 to negative 32, we're going down negative 15. Okay, so again, notice that this change in y pattern is a linear pattern. So we go plus 6, sorry, minus 6, minus 6, minus 6, minus 6. This is a linear change. So again, this quadratic generates a change in y pattern, which is linear. Looking at the next one here, this is the quadratic function, creates these values here. So if we take a look at the changes in y, so 5.5 minus 7 is going to be negative 1.5. 5 minus 5.5 is going to be negative 0.5. 5.5 minus 5 is going to be positive 0.5. And it looks like the change is going to be going up by 1s. Okay, so 7 to 9.5 is going to be plus 2.5, plus 3.5. Again, this quadratic function is generating a linear change in y. So what's happening with the cubic function? If we take a look at the cubic function, okay, this cubic function here happens to give us these values. And we look at the changes in y. So we're going to go 8 over 3 minus negative 9, or plus 27 over 3. So we're going to get positive 19 over 3. Okay, so negative 1/3 minus negative 8/3 is going to give us plus 7 over 3. Okay, so it looks like this has gone down by 12 over 3, or negative 4. Okay, so here from negative 1/3 to 0, we're going to get plus 1/3. Yeah, plus 1/3. Okay, and from 0, we're going to get plus 1/3. Here we're going to get plus 7 over 3 and plus 19 over 3. Okay, so you can double check my work here, but I think I've got it right. We've got our y values for a cubic function generate this pattern. Now this pattern isn't really all that distinctive, but you can see that it is symmetrical. And being symmetrical, we can kind of maybe think, well, this may be a quadratic. In fact, that's true. This is a cubic function. The changes of a cubic function happen to be quadratic. Now we can check that quadratic. If we suspect it's a quadratic, we know that the change in the quadratic here, if this is indeed a quadratic function, the change should be linear. So we show it this way. The second change of y, we use this as the second change. So that exponent is actually not an exponent. It just indicates the second change of y. So if we look at the second change of y, from 19 over 3 to 7 over 3, we went down 8 over 3. Here we went down 6 over 3. Okay, here we went down, or we went 0. Is that correct? So we went down negative 8 over 3. Yeah, we went down 6 over 3. Here we're going to go down 0. And here we're going to go plus 6 over 3. From here to here we go plus 12 over 3. Okay, actually, sorry, this was 12 over 3 here. Okay, so if you take a look at the changes in the second change in y, this really is negative 4, negative 2, 0, 2, and 4. This is a linear pattern. Okay, so the second change of a cubic function happens to be linear, which means that the first change is quadratic. So these changes in y seem to follow this pattern. Okay, and I think we alluded to this before, that if we look at the change of the fourth degree function, well, the first change should be a third degree. The second change of that, a fourth degree function, should be a quadratic, and the third change should be linear. Okay, so there seems to be this pattern of powers that each change function seems to be 1 degree lower, which in fact it is.